So broadly the topic is quality of visual environment. Okay, so it's basically about the lighting. Why it is important? Actually, you see, the good visibility is very crucial. Good visibility is very important because whatever the actions are there of the workers, they will be based on the information that is seen by the worker during the work. So if the visibility is good, to see the workpiece, machines, tools to take the measurement, to perform the operations, so that he can really do the job which is expected. So good visibility is important basically to see the things being used for work. Now there can be lot of difference in the kind of work which is being done. Okay, say it is simply the tightening nut and bolt, you need different kind of the lighting. If it is about the reading and writing, and then you need the different kind of the lighting. If it is the repairing of watch, very fine things need to be worked out, then different kind of the lighting will be needed. And say if it is surgery, where extremely fine thin details need to be worked out for a successful surgery, the lighting is altogether different and of different level. Okay, so to do the job successfully, it is important that whosoever is there, like worker, operator, inspector, doctor, engineer, he must be able to see the things clearly so that he can perform the operations efficiently. So likewise for the shop floor production, worker must be able to see the machines, workpiece, layout, pathways, tools, equipment, so that the operation is performed efficiently, the production is accelerated. So whenever the light visibility is good, you can say in general the efficient operation is realized. Okay, which helps in accelerating the production. The production rate is high production rate can be achieved. Why? Because it will reduce the number of defects. Else you see a lot of issues related with the poor visibility leading to the defects and rejections. Then reduced number of accidents. Another good thing, if you are not able to see the things, then certainly there is a huge scope for the accidents. Reduce wastage. Okay, and if the workers are not able to see the things with the clarity for longer hours, then there will be visual fatigue. Okay, so and continuous visual fatigue for in routine in all the shifts, then it will increase the possibility of the headache. And so for successful performance of the job, about 80% of the information is perceived visually. See, so 80% of the information which is needed for doing a job is perceived visually. So certainly the visual environment must be good enough for performing the job successfully. Okay, and what are the factors that affect the visibility or the visual environment? Visibility or visual environment, it is affected by three factors significantly. So as far as creating good visual environment, what you need to see that there is a correct amount of light. See, so visibility being affected by the kind of visual environment which is there in that, in turn depends upon the amount of light which is there. This is one. And the second is, what is the kind of contrast between the object and the surrounding. So it may be lighting or color contrast between the object which is being object, or you can say the workpiece which is to be seen, and the surrounding, means maybe the work table or the surrounding area where work is being done. So the light or and color contrast between the object and surrounding, this is the second. And third is the quality of light. Quality of light is also important because it can lead to the flickers, or it can lead to the glaring. So glaring and the flickering, these are the two things that will be adversely affecting the visibility or the quality of the visual environment. So these are the three main factors. So additionally, if you see, so these are the factors which will be governing the visual environment significantly, and so the visibility. Visibility, on the other hand, is also affected by number of other related factors. So visibility, like say with what clarity the one is able to see the things. So that in turn it depends upon the size or the dimensions of the object. So you know, with the reduction in size, obviously visibility will be decreasing. So size or the dimensions of the object is one parameter which will be determining the kind of amount of light that should be there. Okay, so that the visibility is reasonably good. The second is the distance between the object and the eyes. You see, there may be a limitation of like a particular distance from which work or job has to be seen during the operation. So if there is a limitation or a restriction on the distance through which or from which this object has to be seen, so distance between the eye and the object, so in general decrease in size decreases the visibility. Okay, similarly increase in distance decreases the visibility, right? Then next factor is, as I have said, the color or lighting contrast between the object and surrounding. So it is expected that depending upon the proximity or vicinity of the different closed surfaces, closed walls or closed light source, that certain ratio of the lighting has to be maintained, so that there is a clear contrast in terms of the lighting of the object, on the object and on the surrounding. Similarly, the color, if there is a good color contrast between the object and the surrounding, then the visibility will be good. So basically it is about the contrast between the object and surrounding. Okay. The next point is about how long time is available. Like if things move very fast, then you may not be able to recognize also like what it was. So similarly, the time available to see the object also affects. So in general, you see, with the decrease in size, increase in distance, reduction in contrast increases the time required to see the things. So if the time is very less, then certainly the visibility will be reduced. Visibility on the other hand, the light intensity so intensity or of the light intensity, or the amount of light which is falling on to the object. Okay, it will also depend upon the many other smaller factors like the ability of the worker, or the age, or how old or new the light source is. So in general, the visibility of the human being decreases continuously with the increase of age, right from, like, say, very few years to 60 years, there is a continuous drop in the visibility. Similarly, the newly installed systems will be giving the light intensity as per their capacity, but very shortly you will see that the illumination level, or the light which is being provided by a light source goes down very rapidly due to the deposition of the dust and the wear and tear of the heating element. So there may be a drop of 10 to 25% lighting capacity of the light source with the time. So it is not good enough to consider that you have installed the light source of the desired capacity and that will continue to supply the same. But the light being delivered or provided by the light source drops continuously, and this can drop 10 to 25% due to the deposition of the dust and the wear and tear of the heating element. Okay, so this is about the factors that affect the visibility. Visibility is also affected by the luminance. Luminance is about the kind of the intensity of the light emitted by a source from a surface per unit area. So like, say, the television or the bulb or whatever notices or advertisements you see, in the background there will be light. So when we check that what is the effect of the luminance in log scale, starting from 0.01 to 0.1, then 1, 10, 100, 1000. It is seen that the visibility continuously increases, and then it becomes constant: 0.5, 1, 1.5 and 2. So it increases rapidly, then it tends to become constant at a higher level. So here the lux, the unit of the luminance, it is also written as candela per meter square, CD per meter square. So if you see here, the visibility improves continuously with the luminance of the light source. It's about the light source. Then if we see other factors and their effect on the visibility, like the time to see increases with the decrease in size, decrease in contrast. Then time to see the things also increases with the visual strain, working hours, muscular fatigue, and with the decrease in efficiency of the worker. So the time to see the things is significantly affected by the many factors, including the size, contrast, the fatigue level, and the kind of working hours which are there. Okay, visibility is also adversely affected with the flickers and the glare associated with the light source. Okay, now we'll see the kind of the lighting or level of illumination needed for doing the any normal kind of work. Okay, so I'll just draw one table to show the kind of the illumination needed in terms of the lux. That's the kind of light which is needed for the different kind of the works. So here if you see like casual seeing, simple like safe, say just for example safe movement, the kind of lighting needed is 20. Okay, for ordinary work like simple say bench work, the lighting requirement is of 150 units. Moderate critical work, okay, say reading, writing, or fine bench work, right? Fine bench work. So this needs around 300 lux. For the critical jobs like stitching or fine bench, or you can say any fine work which is to be done, light requirement is say 700 lux. Very critical job, very critical job, say assembly of fine mechanism, right? The light requirement is around 1500. And very fine and very critical jobs, the light requirement is just like watch repair, then surgery. The requirement of the light may be as high as 3000 lux. Okay, so the requirement of lighting can change significantly with the purpose. The next thing is that if the lighting is not proper, as I have said, then the visibility, due to the poor visibility, there will be chances for the accidents, health hazards, visual fatigue, headache. So all those, to avoid all those things, it is important that as per the nature of the job, as per the worker and his ability, or like the visibility of the worker, or you can say the ability of the worker to see the things, like 6 by 6 or 5 by 5, like that. So depending upon the age, if you see age in number of years and the qualitatively how the illumination requirement is affected, you see. So this is like qualitative illumination requirement. So if you consider that it is, say it is 1 for 40, let me write like this, say for age of 40 it is 1, all right. So for 50 age it is 2, and for 60 it is 5 times. On the other hand, if 30, then it is 2 by 3, and for 20 it is 1 by 2, and for 10 it is 1 by 3. So the lighting requirements increase continuously with the age. Okay, so if this is the reference level, you can see the lesser light will be needed for those younger people, and significantly more light will be needed for those who are of the higher age group. Okay, so this is about the way by which the different factors associated with the work will be affecting the visibility as well as the lighting requirement. Let me see, I'll show you the PPT, and if I have missed something that can be included. So about all this, I have already said good visibility is important. So good visibility of equipment, product, or anything which is involved in work is essential for accelerating production, reducing the defects and wastages, reducing the visual fatigue and headache, and reducing the chances of accidents, because we process about 80% of the information needed for the job that is received through the visual effects, or that is perceived visually. So it is important that this lighting or the quality of visual environment is really good. So this is about the different kind of things about which I have already talked. Okay, it's not sufficient, as I said, it's not sufficient to provide the optimum level of light when the layout is drawn. So why? Because the light intensity falls 10 to 25% due to accumulation of the dust and wear and tear of the lighting system. So it's not like we should forget after installing the required lighting systems. Quality of the visual environment, as I have said, affects or depends on the amount of light, contrast, and the quality of the lighting system, as it will be affecting the glare and flickers. Poor lighting is not good because it will be adversely affecting the health of and safety of workers and their efficiency. It can lead to the eye damages, accidents, wastage, and the reduced production rate. About this I have already talked, like the visibility depends on the quality and the quantity of the illumination, which in turn also, and the kind of the lighting that will be needed, or the factors that affect the visibility include like size of the workpiece, distance of the workpiece from the eyes, light intensity, color, contrast of the colors, and lighting level from the background level of the background, and the worker's age. Okay, you will see few data. This is about the kind of lighting that is needed. This is another slide only. I have already described this. So as I was saying, the illumination level, qualitative level of the illumination which is needed as a function of the age, that increases continuously with the age. About this I have already talked. So this also I have already talked, like installed level of the illumination rapidly falls 10 to 25%, and then more slowly until it is 50%. Then we need to do something under it is recommended that maximum light intensity ratio, this is another thing, like this is an object which is to be seen, so what should be the lighting on the surrounding things. So maximum lighting intensity ratios for providing the optimum level of contrast, that is different. Like say the lighting ratio intensity of the work and the immediate environment, that is 5 to 1. Okay, and the work to the distant surface is 20:1, and the light source or sky and adjacent surfaces 40:1, and the ratio of the lighting intensities of all points in the worker's immediate vicinity and the work, that is 80:1. This is about the reflectance that is recommended, so that whatever the light source is there, that is used efficiently. Like the ceiling reflectance 80, wall 60, desk and bench tops 35, machines and equipments 25 to 30, and floors not less than 25. Okay, this is an important thing about the natural lighting. A good lighting helps to prevent so many things. So natural light should be used as much as possible, and therefore windows should be there. Window area, actually, area of windows, okay, and that of the floor area. This ratio should be 1/6, so that to facilitate the natural lighting. So control and the display devices. This is another very simple topic. So what these devices are and what they do and what we need to talk about them. So these are two different things, like control devices and display devices. So idea behind talking about these is from the ergonomics point of view, like how these should be designed, one, and where these should be located. These are based on the different principles. Few are mechanical, few are electronic in the nature, but from the ergonomics point of view, these need to be designed. How these should be designed means how a control device should be designed and how it should be located. So what are the principles which are used for designing and locating these devices? On the other hand, the display devices, there are a variety of the display devices. So about that I will come later. Let us talk. Let us start with the control devices. So what the control device? This is very simple thing. Like to run the machine, to run or operate any system, you need to give the information or you need to give the signal, so that it will start or it will stop or it will work in a particular way. Okay, so a control device is a device, a control is a device that transmits the signal to a system so that it responds as per the need. Okay, so for performing the different types of the job, different types of the control devices are used. So it's a control devices are like a device which transmits or transmits the signal or any information to the system, to the machine for a desired operation. Okay, since we have a very wide range of the machines and the systems, so we need the different types of the control devices. So few types or you can say the few categories of the control devices are, like say, they will start or stop. So the activate or make the system off. They will start or they will make the system off. So to have this situation, like you need to do something to start a lathe machine, or to start an induction motor, to start a car or a motorcycle, you need to do something. So these devices, so the control devices which will activate or they will put the system off. Okay, so like there can be a push button. You just push once, so it is on, and push again the same, it will become off. So push button. Then there is another type of the device is toggle switch. Then there is a possibility of having the rotary switch. Okay, so a rotary switch you commonly see like in radios, to increase the volume or to change the channel, you use the rotary switch. Push buttons are used nowadays in cars or in motorcycles. So these will activate or they will put the system off. Okay, so this is one. The second type is which will regulate the operation, like it will be increasing the speed, increasing the rate of operation, increasing the flow rate, like that. So regulating the function, so it will increase or decrease. So this can be a qualitative type, like using the fingers you rotate the regulator of the fan. Okay, so it will be rotated. There can be a mark from, like say, of this kind, where very thin and then increasing thickness, or there is a possibility that there is a mark like 1, 2, 3, 4, 5, 6. So and the regulator is moved and rotated back and forth. Okay, so earlier used to have certain steps type, like there are 6 steps of the speed, or nowadays you have infinite stepless regulator. So but what does this 1 to 6 indicate, or what does this increasing width of this sign indicate? It is nothing. It is so the regulating the operation, it can be in qualitative or it can be quantitative also. Okay, so for this purpose, one type of the control which is used is knob. Okay, knob which is used for a number of purposes, like changing the light intensity or changing the fan speed. Okay, so it can be step type, where the control will be realized in certain number of steps, or it can be stepless, where continuous control is possible. In this category only you have others, like a few systems will have like thumb wheel. Few are operated through the thumb wheel. Okay, you just using the thumb you operate it. Then there is a possibility that you use the pedal or foot operated, some kind of the lever, or there is a hand wheel, like it is used in the lathe machine, or likewise number of machines. So these are some of the control devices which are used to regulate the things. Okay, they will help to increase or to decrease or to change the position of the system which is being operated. Okay, so these are various control devices which can be quantitative, which can be and these can be qualitative. Okay, so the knob, thumb wheel or hand wheel, lever, pedal to operate the system at the different stages or condition of the operation. So these can start, stop or regulate type. Then there is a third type which you can see data entry type. Like say you give the command, you write the code, you write the code for CNC machines, you write the part program and give the inputs maybe through the keyboard. Okay, so the data entry type where using the keyboard you give the desired information or command for realizing the desired function. Okay, so you see here in a system there can be the number of what you say, I will write like parts or the members. In a machine there can be number of things. Okay, like this. In the dashboard you may have number of things like this. Okay, but which one is to be used for what purpose? Which one is to be used for what purpose? Like nowadays you will see in the earphones they will write left or right, so they will simply write L or R. Okay, even they will not write specifically that this part or this component in a machine or system is for this purpose. That is not written explicitly, although that is one of the ways. That is one of the ways. So if the operator, when he is working under a strain or he is very tired, not able to see the things clearly, not able to process the information efficiently, or the worker is new. So if in those cases, how to facilitate that the system is operated efficiently and it doesn't lead to the accident, but despite of this accidents occur. I'll give example for that also. So like say there are the different, in the dashboard there are different components and the members. So how to write, how to design those members? Like in a gear lever you will see the sign 1, 2, 3, 4, 5, 6 and R, right? So that it will be indicating the tentative location of the lever for different gearing. Okay, so that is a very simplest way to write the controls, the way by which the system has to be controlled. But there may be many other members, components in a dashboard of a machine, in a control panel of a machine, where you may not find anything explicit. So how to come out with those designs, how to come out with those features so that it is easily identifiable and it is easily recognized. For example, in cars you must have seen people say that it is very easy, like ABC. So first you have accelerator on the right side, then you have brake, and then you have clutch. So on the left side you have clutch, and on the right side you have the brake, accelerator. And so this is the sequence of operation, and what you do basically, there is a left leg for this purpose exclusively. You see, while driving, the left leg is exclusively used for clutch only, right? And the right leg is used to operate both brake or accelerator. Why? Because you will not be doing both the things at the same time. Either you want to accelerate or you want to apply brake. This is one thing. Sometimes when and there is nothing like there is nothing written as such like which one is acceleration and which one is brake. So people will be telling you, even driver training people will be telling you that like the first it is accelerator and then it is brake. It is fine. But when someone is learning to drive, he inadvertently or by mistake, in hurry, instead of putting the leg or applying the force on the brake, he may apply the force on the accelerator and it does just reverse. You want to stop, but it is accelerated. Okay. So, but many times if the codes or the design of the control is not proper, then it can lead to the number of things. So the poor control devices, this can lead to the inefficient operation, even accidents. Okay, and of course the frustration and so many other things. So proper identification of the control devices is very crucial for smooth functioning of the system, because an error in identification of the control devices can lead to all these inefficiency or accidents using the machines. So what is important, that proper identification. The control devices must be designed in such a way that they are identified easily. So it avoids the error. This is one, and improves the performance. And therefore these must be easily recognizable. Once one or operator should be able to recognize these very easily. So what are the ways? People don't write each and everything explicitly, like this is the brake, this is accelerator, this is the switch, this is for a speed increase, this is for a speed decrease. They will use certain things. What are those? So how to come out with the control devices so that these are easily identified and recognized. This is the part of the ergonomics. Like whatever control panel is there, whatever control device is there, that must be recognizable for error-free operation. Okay. So there are certain methods of coding which are used, coding of control devices, to make sure that these are recognized and identified easily. Certain methods of coding the control devices are used. What these methods are, it includes like the size, shape and texture of the control device. This you can say as a one of the same category, although with the little difference. Then second method of coding, you see, you make it of larger size or smaller size or medium size to have the certain functions by the different levers. Okay. Similarly, the shape for certain things may be circular, then hexagonal, then square, then triangular. For the different purposes, you may have the shape of the control panels which are to be used. Similarly, different roughness, very rough or little fine or very fine or medium roughness. So each will have its own problems, that is a fine, but it will have certain advantages as well. So this is one category where size, shape and texture is used for coding the control devices. The second one is location. The similar type of the controls are placed together. This is one. Like I said, ABC, the brake, clutch and accelerator. So wherever you have used like start and off, start and stop kind of the devices will be placed together. So one is in the left side, another is on the right side. So the location is the another one. Like say the first, it is like this. So if you put 1, 2, 3, 4, 5. So pushing 5 may give you the maximum speed. Pushing 1 may give you the minimum speed. So it's also possible like this. Based on the location of the control panel, it may give you the different kind of the functionality. So another method of coding the control device is the location. And we have the size. About the size I have already, size, shape, texture, about these three I have already talked. Then there is a color coding, like green, there is no power supply, or when the system is operation, or the red, or you can like green, yellow, blue, orange. So the different functions can be coded differently, like the start switch is coded with the red, so that whenever there is a power supply, so what is to be the control device which is to be used to start the system may be coded with the red, and something to be for switching off the system, that may be coded with the black or green, like that. So color coding is the another one. Then label coding. Label is another one. Label is like writing the details. Like this is for speed regulator, this is the feed regulator, or this is for the water supply, this is for the oil supply, like that. So you write the details in text. So that is the label coding. Okay. So these are 4-5 types of the coding methods. As I said, size, shape, texture, location, color and the label coding. So all these methods will be used in different places. Like if you have to operate some system in the dark, when there is no lighting, so maybe the shape can help you, but not the color, not the label coding will help you. So if there is a possibility that you may have to use the system when there is no light, then the coding has to be different. The control coding of the control devices has to be different. When you have the situation like the lighting will always be there, then only the label coding or color coding will be fine, because you must be able to see what is written there or what is the color of the control device. Okay, so the advantages and disadvantages of these coding methods I will be talking in the next one. Finally, among these 4-5 methods of coding, like size, shape, texture, location, color and label coding, the choice depends on what? So the choice of the suitable coding of the control device depends on like how many controls you want. Like it is like ABC, just 3 controls in a place based on the functionality. So number of controls to be added. Okay, what is the area available? Area available for locating these controls. Area available for locating these controls. Okay, then what is the kind of the quality of visual environment, whether there will be lighting or it can be dark as well, in which the operations is to be done. So how about the visibility or the lighting arrangement? Okay, how about the operational requirement, like for operating you need to apply a force of 5 kg or just a touch is needed. Okay, so the operational requirement in terms of the force or in terms of the load during the operation, like to operate a particular control, if you need high force or you don't need any force. So it's just like the powered steering or without power steering. This is one. Really, when you switch over from power steering to without power steering, you will find like it's so rough to drive with. Similarly, for trucks which are without power, heavily loaded, it may require a different kind of the force for operating or for controlling the device, controlling the steering. Steering is also kind of controlling device. Okay, then the criticality of operation. Criticality of operation. How critical it is. Like something which is of less importance, less critical, you may choose it differently. If it is extremely critical, then you will put red, you will write text, you will make it big in size, like that. So the suitable choice of the coding. So these are the factors that affect the choice of the suitable coding approach for the control devices. Okay, so the advantages and disadvantages related with these coding methods for control devices, that will be taken up in tomorrow's lecture. And lastly, what are the display devices and what are the technical aspects related to the design of the display devices, what are the different types of the display devices, that we'll be talking in the next lecture. So initially I will start with the lecture only, and maybe in the second half of the lecture, in tomorrow's lecture, I will be going through this test. Okay.